Hello everyone, in this video I'm going to speak about converting volume of gases to number of moles. Let's get started. The most important formula that you will use in this lesson is 1 mole of any gas occupies 22.7 cubic decimeter only at STP. What's STP? It is standard temperature and the pressure, where the temperature is equal to 273 Kelvin and the pressure is equal to 1 atm. The ideal gas is a gas under STP, and the ideal gas can deviate to become a real gas under two conditions: low temperature, high pressure. Number of moles of any gas at STP is equal to volume over molar volume. The molar volume in our case here is 22.7, of course, at STP. Let's check a problem. Assuming that gas behaves an ideal gas, calculate the volume of carbon dioxide produced when 100 cubic centimeter of ethene burns in excess oxygen according to the equation here. First step is to write the equation. Second step is to write what we have. We have 100 cubic centimeter of ethene and we'd like to find the volume of carbon dioxide produced. What we can do here, we can just cross multiply the volume by moles. Why we can do that? Because we have a formula which says that number of moles equal to volume over molar volume. Molar volume at STP is 22.7. Nothing to say that's STP here, but we have an ideal gas and we have like fixed conditions. So at fixed conditions, we deal with volumes like moles. It means that if we divide it over 22.7 here, and if we divide it here over 22.7 here, this will be cancelled with this one, so there is no change will happen to the formula. So, at fixed conditions, we deal with volumes like moles, so there is no need to convert the volume into moles. So the volume of carbon dioxide is equal to 100 by 2 all over 1, so it's 200 cubic centimeter. Let's check another problem. Calculate the mass of sodium carbonate that must be reacted with excess hydrochloric acid to produce 100 cubic centimeter of carbon dioxide at STP. I will write what concerns me in the equation, sodium carbonate and the carbon dioxide, what I have in the problem, 100 cubic centimeter of carbon dioxide, and I would like to calculate the mass of sodium carbonate. What I cannot do here, I cannot cross multiply to find the mass because I have volume, but I can cross multiply to find the volume of sodium carbonate because, as we said, at fixed conditions or at STP, we can use the volume like moles. So the volume of Na2CO3 is 100 because they have the same mole ratio, 1:1. So if we have 100 cubic centimeter carbon dioxide, we'll have 100 cubic centimeter of Na2CO3. Now we'd like to find the number of moles of Na2CO3 because we cannot move from volume to grams directly. We cannot move from volume to grams directly, but we should go through the number of moles. How we can do that? We'll use the formula. Formula is telling us that number of moles equal to volume over molar volume. So the number of moles is volume, but we have to use the volume in cubic decimeter. For that reason, you can see here I'm multiplying by 10 to the power negative 3 to convert the cubic centimeter into cubic decimeter all over 22.7. Then we have the number of moles of sodium carbonate. Okay, so now it's easy. We have number of moles. We already know that N is equal to mass over the molar mass. So we can easily find the mass of sodium carbonate, which is equal to number of moles by molar mass. Have the number of moles, we have the molar mass from the periodic table of Na2CO3. Then we can find the mass very easy.